9.10, similar right triangles altitude to hypotenuse. Number 1 says, given right triangle ABC, so this whole triangle, with an altitude BD. What an altitude does is it drops down. Think of altitude of a mountain. You're measuring it really from the top point all the way straight to the ground. It's not the slope part. It's actually its altitude straight up, making 90-degree angles with the ground. And if AC is 4, they've already got everything labeled. And that should say DC is 3. What is the length of BC in simplest radical form? So what you need to know is that this creates 3 similar triangles. Creates 3. And the reason why it creates 3 is because you've got this little one here. So I tilted it, I rotated it 90 degrees clockwise, and D is at its right angle. It goes up to A and over to B, so here it is, D, A, B. So flip that, or picture that being flipped. Then I also have this one, this kind of medium-sized triangle. And that one I left in that orientation where it's D, B, C. And I just went on and labeled everything. And then I've also got the entire triangle, which needed to be flipped kind of upside down here because my right angle is B. So I flipped it so where I have B, A, C. So it created a small, a medium, and a large triangle. And I labeled everything. So now all I'm trying to do is use a proportion to solve, which is what we've done. I'm not using this actually at all because there's no measurements there. But I could say X is to 4. X is to 4 as 3 is to X. And I cross multiply. X times X gets X squared. 3 times 4 is 12. Square root both sides. Once it in simplest radical form, 12 can be broken up into a square root of 4 times the square root of 3, and that would be 2 square roots of 3. Would be my answer. Okay, and then number 2, see if you could draw 3 different triangles. I'm going to keep this big one exactly like it is, actually. So I'm going to have a small or a big, and then that's C, B, A. This is X, and this whole distance 24. Okay, then I'm going to draw a medium one. My medium one comes from here. My right angle is at D. So picture flipping this over, reflecting it almost. So D out to B, up to A, and then a small one. And this small one, again, right angles at D, and it goes out to C and up to B. And then in this one, I know BC is X and CD is 6. So I'm actually not using the medium one at all. So I could have something like X is to 6 as 24 is to X. X times X is X squared. 24 times 6 is 144. Square root that. I actually get positive and negative 12, but remember we're not going to use the negative, so it's just 12. Now, before you stop the video and stop listening, there actually is an easier way to do this if you can remember it. What happens is if I'm trying to find a leg, let's see, where can I write this? I'll put it at the bottom. But if I'm trying to find a leg here, a leg meaning of the whole triangle, because this was a leg in this, I could say that the leg squared equals piece of the hypotenuse touching that leg times the whole hypotenuse. So it'd be X squared equals 3 times 4, which is exactly what this became. So I would not have to create a proportion. Let me try it on this one. So in this, I would want to find this leg. So I would have X squared equals piece of hypotenuse touching that, which is 6, times the whole hypotenuse, which is 24, which is exactly what I had. X squared equals 144. So I'll write that down. That only works when you have an altitude in a right triangle. So it's leg squared equals a piece of hypotenuse. And it's got to be touching the leg you're using times, or maybe x times, whole hypotenuse. So it's up to you. If you like just making the triangles and doing it like we've been doing it, fine. If you can remember this, that's fine as well.